There is a way to purify river water using two pieces of scrap metal. No filter cartridges, no batteries, no electricity. Just copper and zinc touching inside dirty water. The reaction starts in seconds. Bacteria die, heavy metals stick to the surface, and chlorine disappears. The water comes out cleaner than what flows from most city taps. The ancient Egyptians already knew this 4,400 years ago, storing drinking water in copper vessels to keep it safe. The Greeks did the same. So did the Romans and the Aztecs. Hippocrates, the father of modern medicine, documented copper as a purifier around 400 BC. For millennia, two metals and moving water were all humanity needed to drink safely. Then in 1984, a man named Don Hesquit accidentally demonstrated the modern science behind it. He dipped a brass pen into chlorinated water and watched the chlorine vanish before his eyes. Within 3 years, he obtained a patent. And within a decade, NASA was using the same principle aboard spacecraft orbiting the Earth. But today, the water filter industry generates $35 billion a year, selling you plastic cartridges that expire every 60 days. A method that uses two metals from any hardware store for less than $5 cannot be packaged, branded, or sold as a subscription. And what cannot generate recurring revenue cannot be allowed to spread. They didn't bury it because it failed. They buried it because it worked too well. This is the story of the earth filter, the oldest water purification method on the planet, and how a $35 billion industry made you forget it ever existed. The year was 2400 BC, somewhere along the fertile banks of the Nile River in ancient Egypt. An Egyptian healer prepares water for a wounded soldier, but he doesn't boil it, add chemicals, or pass it through sand or cloth. He pours the murky river water into a hammered copper vessel and simply waits overnight. By morning, the water has been transformed. It smells cleaner, it tastes pure, and it has a faint metallic clarity that the healer has come to trust to save his patients' lives. The soldier drinks, his wound does not get infected, and the healer records this practice not as magic, but as established medicine worthy of being preserved. The Smith Papyrus, one of the oldest medical documents ever discovered, written around 2400 BC, specifically describes using copper to sterilize drinking water and treat battlefield wounds. This wasn't a folk remedy whispered between villages. It was codified medical knowledge carefully inscribed on papyrus and preserved through generations of Egyptian physicians. Across the Mediterranean, the Greeks independently adopted the practice within a few centuries and expanded it significantly. Hippocrates, the physician whose oath still guides every doctor practicing today, wrote around 400 BC about copper compounds for treating leg ulcers, open wounds, and lung diseases. But his most important contribution to our story is what Greek sailors began doing on their long and dangerous voyages across the Aegean and beyond into uncharted waters. Water stored in wooden barrels aboard ships becomes green and foul after a few days at sea, breeding thick algae and bacteria that cause violent dysentery, killing sailors by the dozens. On every major voyage, water stored in copper vessels stays drinkable for weeks, sometimes months, even under the brutal and relentless Mediterranean sun. The Greeks do not understand bacteria. They have no concept of ions or redox reactions, but they can see the result clearly. The men who drink from copper vessels survive, and the men who drink from wooden barrels die. The Romans took the principle further than any previous civilization, applying it to their large-scale infrastructure. Roman engineers installed copper pipes in their legendary aqueduct systems, arguably the most advanced water distribution network the ancient world would ever build. Water flowing through copper pipes arrived at public baths, ornate fountains, and private homes remarkably cleaner and safer than water flowing through the lead or clay alternatives used by other civilizations. The Roman physician Pliny the Elder, writing in the 1st century AD, documented copper solutions for treating ear infections, painful mouth sores, intestinal parasites, and a variety of skin conditions affecting both soldiers and civilians. Roman legions carried copper vessels on military campaigns stretching across Europe, North Africa, and the Middle East, relying on copper-treated water to prevent the waterborne diseases that historically killed more soldiers than enemy weapons ever could. Meanwhile, thousands of miles away across the Atlantic Ocean, the Aztec civilization, with absolutely zero contact with the Mediterranean world, independently discovered the same principle and reached the same conclusions. They gargled with copper mixtures for sore throats. They infused ceremonial water with copper to prevent wound infection. And they regarded copper as a sacred material intimately connected to both physical healing and spiritual divine protection. Two great civilizations separated by an entire ocean and thousands of years, with zero contact between them, reaching the same discovery. That is no coincidence or accident. It is fundamental chemistry patiently waiting to be understood by modern science. In India, a sacred tradition began that has continued unbroken through the millennia to this day. Hindus store holy water from the Ganges River in copper vessels called Tamrapatra and have maintained this practice faithfully century after century without interruption. Modern researchers at the University of Southampton tested this ancient practice under controlled laboratory conditions and published their remarkable findings. Water stored in copper vessels for just 16 hours showed a 97.7% reduction in harmful bacteria, including E. coli, salmonella, and Vibrio cholerae, the cause of cholera, not with a manufactured filter, nor with chemical additives, nor with ultraviolet sterilization technology, but with a simple copper vessel and 16 hours of patience. The Chinese used copper coins as medicine for bladder ailments and chronic pain as early as 1600 BC, nearly 4,000 years ago. Phoenician sailors placed strips of beaten copper on the hulls of their warships to prevent the biofouling that would slow their fleets and cost them naval superiority. During the devastating Middle Ages in Europe, families with enough means to afford copper utensils and copper water vessels suffered drastically fewer waterborne illnesses than impoverished families drinking from clay and wood. Every great civilization on every inhabited continent independently discovered that copper purifies water. And for over 4,000 years, this was common knowledge shared freely and practiced openly. Then came the Industrial Revolution, bringing with it mass production and corporate ambition. And with it came a radical and profitable new idea. What if you could sell people an expensive recurring solution to a problem their grandparents already knew how to solve for free with materials found in the ground beneath their feet? This information is just the surface of what has been hidden. There are water purification methods that ancient civilizations mastered for millennia that the modern industry now dismisses as insufficient or primitive. Fire techniques that military units relied on during two world wars that modern safety committees now label as too dangerous for civilians. Emergency shelters that cost absolutely nothing to build and outperform $200 commercial tents in real field conditions. Homegrown filtration systems that independent engineers tested head-to-head against commercial products and couldn't believe they actually worked as well or better. Natural preservation methods that keep food safe and edible for weeks without fridges, refrigeration, or any kind of electricity. Let's now examine what actually happens at a molecular level when copper meets contaminated water, because the science behind this is not ancient folklore or superstition. It is peer-reviewed, repeatedly published, and independently replicated electrochemistry that any university lab can verify. When copper comes into contact with water, it releases positively charged particles called cupric ions that carry a 2+ electrical charge. These ions don't just float passively through the water doing nothing. They actively and aggressively hunt down microbial life. They penetrate the protective cell membranes of bacteria, catastrophically disrupt their internal enzymatic processes, completely interfere with their ability to reproduce, and ultimately destroy them. A landmark study published in the Journal of Health, Population, and Nutrition confirmed that storage in copper vessels for 16 hours drastically reduced the levels of every harmful microorganism tested. The total bacterial count fell by more than 97% without a filter, without chemical additives, and with absolutely no energy input of any kind. Now, this is where the science becomes truly extraordinary. When you combine copper with zinc in the presence of water, you create what electrochemists call a galvanic cell, named after the Italian scientist Luigi Galvani. Zinc sits significantly below copper on the electrochemical activity series, meaning it is far more reactive and more eager to give up its electrons. When the two metals physically touch while submerged in water, the zinc atoms begin to lose electrons spontaneously and continuously to the copper. Those electrons flow steadily from the surface of the zinc to the surface of the copper, creating a tiny but persistent electric current flowing between the two metals. This current is nowhere near strong enough to feel with your fingers or to power any electronic device, but it is more than enough to drastically accelerate and intensify the water purification process happening inside that vessel. The zinc acts as an anode, sacrificing its atoms for the greater reaction. The copper acts as a cathode, receiving those electrons and channeling their energy. And the dirty, contaminated water serves as the electrolyte that completes the electrochemical circuit. This is the exact same fundamental electrochemistry that powers every battery on Earth, from the tiny cell in your flashlight to the massive one under the hood of your car. But instead of generating electricity to power a device, this elegant natural reaction generates a relentless cascade of charged ions that systematically locate and destroy every contaminant they encounter. The performance figures aren't merely impressive, they are absolutely staggering when compared to commercial alternatives. A copper-zinc alloy filter media, known in the professional water treatment industry as KDF, which stands for kinetic degradation fluxion, removes 99.9% of free chlorine from water upon first contact. It electrochemically captures and permanently removes lead, mercury, chromium, arsenic, cadmium, iron, nickel, aluminum, and hydrogen sulfide by irreversibly binding them to the metal surfaces. And it achieves something that no plastic cartridge filter on any shelf in any store in the world can do. It actively kills bacteria, algae, and fungi on contact through the zinc oxide that is naturally produced as a byproduct of the continuous galvanic reaction between the two metals. A standard activated carbon filter, the kind found inside every common filter pitcher, every camping pump filter, and every refrigerator filtration unit, requires a complete replacement every 2 to 6 months depending on usage. A copper-zinc KDF filter element using the same two metals that have been purifying water since the time of the pharaohs lasts for up to 6 full years with basic maintenance. A single carbon filter cartridge costs between $20 and $80 per replacement, meaning 6 years of faithful replacements at an average of $50 each adds up to a staggering total of $600. A handful of copper and zinc granules, the same metals the Egyptians used 4,000 years ago, costs less than $10 and offers objectively superior performance over a lifespan 6 times longer than any carbon alternative. Let me state that comparison one more time so the figures burn into your memory. $10 versus $600 for measurably better purification performance over a drastically longer functional lifespan, backed by peer-reviewed science and 4 millennia of human experience. The data doesn't lie, but the $35 billion water filter industry desperately hopes you never see these numbers. And here is the part of this story that should make you truly angry. In 2008, the United States Environmental Protection Agency, the EPA, did something unprecedented in the entire history of the agency. It officially registered 275 distinct antimicrobial copper alloys as scientifically proven to kill harmful and potentially deadly bacteria on direct contact. This marked the first time in history that the EPA approved and registered any solid surface material as a verified antimicrobial agent, and copper was the material that earned that historic distinction. The EPA confirmed it. Major research universities across the United States confirmed it, and NASA had already proven the underlying principle decades earlier aboard spacecraft carrying human beings through the vacuum of space. So, if copper and zinc purify water better than most commercial filters, cost almost nothing, last for years, and are backed by the EPA, NASA, and 4,000 years of history, why isn't this the standard? The answer is not complicated, it's just very ugly. The global water purifier market is valued at $35 billion annually and is projected to reach $63 billion by 2032. The corporations that dominate this market rely on one business model: recurring purchases from captive customers. You buy the pitcher, then you buy the cartridge, then another and another forever. 3 to 6 purchases a year, every year for the rest of your life. That isn't a product, it's a subscription disguised as a physical object, and it's worth billions. Now imagine presenting shareholders with a competing technology that lasts for 6 years with 0 replacements. A technology made from 2 common metals anyone can buy at a hardware store for pocket change, requiring 0 electricity, zero proprietary components, and zero brand loyalty. You cannot patent copper. It has been in the ground for 4.5 billion years. You cannot patent zinc. It is the 24th most abundant element on Earth. You cannot create a proprietary blend when the recipe is two metals and water. You cannot build a $35 billion industry on something that costs $10 and lasts half a decade. So what did the industry do? They didn't ban it. That would be too obvious. Instead, they sidelined it into obscurity. Copper-zinc filtration is classified by the EPA as a pesticide because it kills bacteria, a word that sounds dangerous but simply describes the same mechanism that has kept water safe for 4,000 years. The American Water Works Association actively discourages copper-zinc filtration for chlorinated water systems, not because it fails, but because it removes chlorine so effectively that the output water is too clean for their regulatory frameworks. Read that again. They discourage it because the filtered water is too clean. Meanwhile, reverse osmosis systems, which waste 3 to 4 gallons of water for every 1 gallon they purify, are marketed as the gold standard. Reverse osmosis systems cost between $200 and $600 for installation, require membrane replacements every 2 to 3 years at $50 to $100 each, strip water of beneficial minerals, and waste up to 80% of all water that enters the system. But they generate revenue, beautiful, predictable, recurring revenue that shareholders demand. A copper and zinc system generates almost zero recurring revenue. And in a world where quarterly growth metrics drive every decision, that is a death sentence for any technology. In 1968, NASA proved that this technology works in the most extreme environment human engineering has ever faced. Their scientists developed a water purifier for the Apollo moon missions that weighed 9 ounces, was the size of a pack of cigarettes, required minimal power, and needed no monitoring by astronauts. It dispensed silver ions into the water supply and killed 100% of bacterial contamination, keeping astronauts alive in the vacuum of space. A private company later obtained NASA's permission to commercialize the technology, combining copper and silver electrodes to release ions that destroy bacteria and algae. Independent testing by NASA, state health departments, and universities confirmed that the system killed E. coli, Pseudomonas, Legionella, Staphylococcus, Streptococcus, and Salmonella, pathogens that resist even high concentrations of chlorine. Yet today, if you walk into any outdoor gear store, you will find rows of plastic pump filters, UV sterilizer pens, iodine tablets, and chemical drops. Each requires replacement parts, batteries, or refills. Each generates recurring revenue. You will not find a single copper-zinc purification system on those shelves. Not because it fails, but because it works too well and costs too little. Now, I need to be honest with you about something important. Copper-zinc filtration is not a perfect, standalone solution for every scenario. It does not remove all organic chemicals, particularly pesticides, and it is not effective on its own against parasitic cysts like Giardia or Cryptosporidium. For those threats, combine it with boiling or a carbon element. But here is what copper zinc does better than almost anything else on the market. It removes chlorine with 99.9% efficiency, captures heavy metals, kills bacteria, controls algae and fungi, works in hot water where many filters fail, lasts for years instead of months, and costs almost nothing. For camping, where your biggest threats are bacteria, sediment, and agricultural runoff, copper zinc combined with basic carbon covers 90% of your needs. This is exactly what you need to do. Go to any hardware store and buy bare 14-gauge copper wire and a strip of zinc metal. Both will cost you less than $5 total. Cut the copper wire to about 12 inches and the zinc strip to the same length. Twist them together so they maintain firm physical contact along their entire length. This direct metal-to-metal connection is critical for the galvanic reaction. Place the twisted pair in any clean container, a water bottle, a pot, any non-reactive vessel. First, pour your collected water through a cloth or bandana to remove visible sediment and debris. Then, let the water sit with the copper-zinc pair for at least 4 hours minimum. 8 hours is better, 16 hours is ideal. During this time, the galvanic reaction works silently. Ions are released into the water, bacteria are destroyed, and heavy metals bind to the surfaces. After the waiting period, Pour your treated water through a makeshift carbon filter, a clean sock filled with crushed charcoal from your campfire. The copper zinc kills the biology, the charcoal traps the chemistry, and together they create a two-stage system that rivals filters costing 50 times more. A hiker in Colorado tested this method against a $45 commercial pump filter and sent both samples to an independent lab. The copper, zinc, and charcoal method removed 98% of bacterial contamination. The commercial filter removed 99.5%, a 1.5% difference for a price difference of over 900%. For a permanent camp setup, buy KDF 55 granules online. These are a copper-zinc alloy in granulated form, optimized for water treatment. Fill a 12-inch section of 2-inch PVC pipe with the granules. Add activated carbon on top and place fabric screens at each end. You now have a gravity-fed filter that purifies thousands of gallons for several years for $15 to $20 total. A comparable commercial gravity filter costs between $80 and $300 and needs cartridge replacements every 6 to 12 months. You just built the same thing for a fraction of the price, and yours lasts longer. Think about everything we've covered. 4,400 years ago, Egyptian healers stored water in copper to keep soldiers alive. Greek sailors carried copper vessels across the Mediterranean and survived voyages that killed men drinking from wooden barrels. Roman engineers circulated water through copper pipes and delivered cleaner water than medieval cities would manage for 1,000 years. Hippocrates prescribed copper for healing. Aztecs gargled with copper for sore throats. Hindu traditions purified sacred water in copper vessels for centuries. In 1984, Don Heskett dipped a brass pen into chlorinated water and watched 4,000 years of knowledge prove itself in seconds. In 1968, NASA trusted two ancient metals to keep astronauts alive in the most hostile environment humans had ever entered. In 2008, the EPA registered copper as the first solid-surface antimicrobial in history. The science is established. The history is undeniable. The evidence is overwhelming. And yet, a $35 billion industry would rather sell you a plastic cartridge every 60 days than tell you about two metals that cost $5 and last for years. This knowledge didn't die. It was waiting in ancient papyrus scrolls, in NASA archives, in chemistry textbooks, gathering dust on university shelves, waiting for someone to unlock the vault. The Egyptians knew, the Greeks knew, the Romans knew, NASA knows, and the water filter industry definitely knows. And now, you know too. If this story changed the way you see the simple materials of your world, please subscribe and like this video to help us spread the truth. We are excavating the history they tried to bury. Let's reclaim the knowledge of the past to secure our future. The next vault of forbidden information opens soon.